So we are doing examples of differentiation and integration for bases other than E. Now, if you haven't watched the content video, I did the differentiation examples, the derivative examples at the end of that video. So if you did not watch the content video, you need to go back and look at examples 1 and 2, which show you how to take derivatives of the logarithms and the exponentials that are not base E. So this video is only going to look at the integration part of it. All right, which is a little bit more involved because you got to do use substitution and so forth. All right, so if you remember to integrate a base that is not base E, it's its own antiderivative, but then you have to divide by the natural log of the base and then add that plus C. So this one's pretty straightforward here. We just have 2 to the x. So he's his own antiderivative, but then we have to divide by the natural log of the base, which is 2, and then add my plus C. So there's our answer. Now this one might do a use substitution because it's not 5 to the x, it's 5 to the negative x. So I might just do a use substitution. Whoops, it didn't change. All right, let's try that again. Green, green, green. There we go. So u equals my negative x, my exponent. So du is going to equal negative 1 dx because I just took the derivative. So dx equals a negative du. So now I'm going to trade out. So this is 5 to the u. And in place of dx, I'm going to put negative du. So I just have an extra negative. So when I do my antiderivative, I'm going to keep the negative answer. F to the u is its own antiderivative, but we have to remember to divide by the natural log of our base 5 and then add c. And then we just plug our u back in. So this will be negative 5 raised to the negative x divided by the natural log of 5. Plus c. So what you expect here, the only thing that's extra is this little negative sign because the derivative of this 5 to the negative x would be multiplied by a negative 1. So we'd expect a negative to show up. So these are not too much different. All right. I just find that if you don't have just x by itself, the easiest thing to do is to do a use substitution, and that way you're not going to mess up. Okay. All right, so for this one, I'm going to do the same thing. I'm going to do a u substitution because I have 2 raised to the sine x, not just 2 to the x. So I'm going to let u be sine x because I was hoping this was 2 to the x. It's not. It's 2 to the sine x. So I'm going to let my exponent be my u. So now I'm going to take the derivative. Du equals the derivative of sine's cosine. And then I put a dx. And now we're going to solve for dx by dividing by cosine. So now we're going to trade out. This is going to be 2 to the u, and then I'm going to keep the cosine, and then I'm trading out the dx. In place of the dx, we're putting this right here, the du over cosine, which, voila, what we hope happens, the cosines cancel. So really, I'm just integrating 2 to the u du. Okay? Now, we know 2 to the u is its own antiderivative because we're in u's. So the antiderivative of 2 to the u when you're in u's is going to be 2 to the u. Then you have to divide by natural log of the base, which is 2, and then add your plus c. And so now I just need to put my u back in. So this is going to be 2 to the sine of x divided by natural log of 2 plus c. So there's my answer. And again, you should never get these wrong. You should never, when you integrate, you should never get them wrong. You should always try, if you're unsure, take the derivative of your answer, and you should get the original problem up here back. Alrighty, so this one just wants us to do a fundamental theorem of calculus. So we got limits of integration. We have numbers here. So we're finding the area underneath the equation 3 to the x on the interval from 1 to 4. So I need the antiderivative of 3 to the x. Well, that's going to be 3 to the x divided by natural log of 3, because you just divide by the natural log of the base. And then I don't need the plus c because I'm evaluating from 1 to 4. So I do my little bracket and I put 1 to 4 on there. So now I do the fundamental theorem of calculus. I put a 4 in first. So that's going to be 3 to the 4th over ln of 3. And then I minus and put a 1 in. 3 to the 1st divided by ln of 3. And we're not going to use a calculator or anything, but these do have a common denominator. They have natural log of 3, both of them do in the denominator. So this is going to be 3 to the 4th minus 3 to the 1st. Well, 3 to the 4th is 81. So this is 81 minus 3 to the first is 3. So our final answer is going to be 78 over the natural log of 3. So this is the area under the curve 3x on the interval from 1 to 4. So if you math 9 to this, remember you can always math 9 to check your answers. You still have to know how to do them by hand, but you can always check your answers. Math 9 this, put this integral in the calculator, get what your decimal is. And then when you divide 78 by the natural log of 3, you will get the exact same decimal approximation. All right, good deal, good deal. All right, so that was it. Taking the derivative and natural log of functions that are bases that are not e is not too difficult. And it's not a real heavy part of the AP exam, just maybe one question or so on the whole test on this topic. Is not real heavy on the AP exam. But here are some practice assignments for you to try. And I'll answer any questions you have when we see each other next.